111. All right, I guess we have to start because this is exactly the time to start. And welcome. Hi, everyone. And first of all, thank you for coming. This is not trivial talk. Today we are going to do some hardcore, to look at some hardcore, and afterward to build some reactive library like RxJava or Project Reactor. So before we are going to start, I want to save your time, since your main goal today is to learn something new, right? Have you already learned something new today? Just raise your hand. One person, two person. I hope everyone should learn at least something, at least one thing new today. So I guess in case you have never learned, if you haven't had a chance to learn something new, today you are going to learn lots of new things. But again, I want to preserve your time, so you will be able to switch to another session, to parallel session. So I need to say for whom this talk and state clearly what we are going to do today, right? So let's do that first. This talk is for all people who are reactive adopters or want to start Bane 1. So how many of you are doing reactive programming today using RxJava or Project Reactor? Just a few hands. Who want to do that? Oh, yeah, that's great, everyone. So this talk is exactly for you, because at some point in time you decided to start debugging all these reactive streams, right? Because this is production, you can get a bug or issue in production, so you would have to start debugging things. And today we are going to look inside the library, so you will be able to understand where to put your breakpoint afterwards. Does it make sense? Yeah. So you will be able to step by step debug everything, because you will be able to you will learn how it works. And the most important part, the internals is not the trivial of reactive libraries. So we are not going to look at the plain API. We are going to look at the internals. So you'll be able to learn what patterns are used under the hood and what concurrency practices are hidden inside it. Because there is lots of concurrency patterns in order to make everything non-blocking and asynchronous. So we are going to look at them. And afterwards, you'll be able to understand why it's so hard and unclear inside of the library. And finally, as it was for me, for example, at some point in time when I was CTO at some startup, we had to replace some operators, because we knew how specific part of our flow works. So we knew what particular guarantees do we have in that flow. Oh, thank you. Yeah. Yeah, 3-hour session, so I had to have some coffee with me in order to not sleep. And at some point in time, we required to customize some particular part of the library or operators in order to make it much more faster. Because we know that there is no concurrency in there, so we have to just supply from one stream without any back pressure control, etc., and so forth and so on, as you will see. So if there is some need from you to cover this topic, to understand those topics, this is the right place, and I will be explaining all these internal things. All right? Are they good? Are we ready to go? Great. So let me introduce myself. My name is Oleh. I'm from Ukraine, from Kiev, so it's pretty close from here. I'm committed to Project Reactor, so I did a few of operators to Project Reactor. I fixed a few bugs there. Also, I've worked for Netify, and at Netify we are doing RSocket. So if you have never heard about RSocket, I'm welcoming you to visit tomorrow topic, which is multiplayer Pacman with RSocket. This is also reactive streams, but over the network. So I saw reactive streams from every side, like network communication as part of the library, so I knew everything about reactive streams. And if you want to visit Kyiv at some point in time, so I'm welcoming you to visit Devoxx Ukraine. This is a great conference to learn something amazing as here, but in Kyiv in Ukraine. So yeah, let's start. Yeah, of course, yeah, forgot. Every time I forgot about the slides. I've wrote a book about reactive programming and reactive streams in Spring, so if you're curious, just let me know, and I will share some PDFs with you for free. So yeah, it's up to you. Our today's agenda. First of all, we are going to start with reactive streams, and we are going to understand what is that, why it was invented, and what is hidden inside this specification. Then we are going to build the most complex part of Reactive Streams, which is publisher. So we will start with implementing the publisher from the beginning to the very end. It will be one publisher, but that would be enough to understand why it's hardcore. And afterwards, we're going to build a Reactive library, because once we understood how to build your own publisher, it will be just really simple task to build the rest of the library, believe me. OK, so how many of you heard about Reactive Streams today, or by today? Almost everyone. In general, for those who haven't heard about Reactive Streams, this is a specification, a particular document, which states that in order to standardize all reactive libraries, all kind of reactive streams, we have to introduce a few interfaces. Thank you. He is amazing. And there was introduced a few interfaces, like 3 main interfaces, like publisher, subscriber, and subscription, and 1 additional, which is combination of subscriber and publisher. And the final things, the most important, as for me, as from my point of view, is backpressure support or flow control. How many of you heard about flow control or knew what backpressure is? OK, a few hands. So I need to explain to the rest of the audience why backpressure is really important, right? Does it make sense? I need 1 volunteer from the audience who want to support me in this demonstration. This is really a simple demonstration. Don't be shy. You would have to throw balls into me. So who wants to throw balls into me? OK. Thank you. So it will be a really simple game. Just take all these balls. And now, just imagine what we are doing in normal network communication, like what we are doing when we write some client-server communication. We create clients which sends requests as fast as possible, right? Yeah, that's what we are doing from client-to-server communication. So now we are going to simulate client-server communication in the normal HTTP way, for example. So what does it mean? Once I start it up, I say, I'm ready, right? And the client should start sending balls as fast as possible. Yeah, as fast as possible, just throw it. But I have only a limited capacity, right? And every server in the world has limited capacity. Stay with me, so don't be too far from here. And that's why once the client starts sending too many requests to the server start being unresponsive, right? So it starts dropping some messages, and for some cases, it's absolutely unacceptable. Just imagine that you are sending bank transactions. It's impossible to lose 1. So you have to preserve every. And of course, you will start inventing such things like circuit breaker. You will start doing retrievement of the delivering of the request. You will start implementing timeouts, and you will start creating too many things, which will just complicate your simple application that just have to deliver a message. So what we can do, since we know that, for example, I have only a limited capacity of 2 hands, which can handle only 4 balls at the same time, in good case, right? What should I kind of implement any different semantics instead of saying from server to client how many kind of requests I'm ready to handle? So since I know my capacity, why I just don't say to my producer how many I want to handle? Just imagine the same semantic. Once I started, I'm saying I'm ready. But now, in order to make some flow control, to specify to publisher how many of messages I'm ready to handle at this point in time, because anything could happen. For example, someone could call me and 1 hand just went out because I'm just looking at my phone. So everything could happen, and instead of to preserve the stability, I would rather say how many I'm ready to handle at this point in time, and if something went wrong, I will just stop saying how many I'm ready, so publisher will stop saying that, right? Does it make sense? So now just see, I'm ready to handle 3 balls. So just send with the same speed 3 balls, and that's good. I asked 3 balls, now I'm ready. Just imagine that everything is asynchronous, and I can put my balls at the same time while I'm handling. So I handled 3 of them, and I'm ready to handle another 3. Please, throw it to me. And now you see, the speed of sending is almost the same. Like this is the same streaming of elements of requests, but now I'm ready to preserve stability because I am able to say at a particular moment in time how many I'm ready to handle. Yeah, thank you. That's it. That's whole demo. Does it make sense? Do you understand backpressure right now and importance of backpressure right now? Do you? OK, great. So I'm almost done. This is the whole presentation. I'm joking. So now you understand why back pressures is really important, and because of that, the back pressure were implemented inside Reactive Streams as a part of standard. So let's take a look at the interfaces. The publisher or producer side is really plain. So we have only one method which accepts subscriber, and that's it. Is it simple? Yeah, it's pretty simple. On the other hand, subscriber is a little bit more complex, but it's still not the rocket science. We have a few methods here, like we have, oh no, this is not the right highlight. We have only main three methods like onNext, onError, onComplete, which allows you to send signals asynchronously, like I want to send some data over onNext, then I want to declare that I got some error over onError, or there is nothing to send over complete. And we got an additional method called subscription. And subscription on subscribe here, which passes subscription to us. And this is basically the new contract between publisher and subscriber, because over subscription today, you can control back pressure. So this is exactly the way I have shown, which allows you to asynchronously specify how many elements the subscriber want to get at this point in time. Does it make sense? Great. So this is really simple. If you're going to put everything on the map, and we'll try to write some communication between publisher and subscriber, we will see the following. There is a publisher, there is a subscriber. In order to start getting some data, subscriber have to say, subscribe me, please, give me some data. This is a request. So the publisher will send a subscription to subscriber over unsubscribe, and subscriber will be able to say, okay, now I want to get 5 elements because I know my capacity, so please give me 5 elements. And publisher, due to contract, should send only 5 or less elements and not more. And if in case there is a completion, it will be sent a completion signal. Is it simple? Yeah, it's pretty simple. So let's try to implement our own publisher, since we know that there is only one method, so it should be just a lambda in some cases, or one anonymous class. It shouldn't be that hard. So let's try to create array publisher, just in case. So we have an array. This is almost used array. This data structure is used in any cases. It could be a queue, it could be whatever we want. So it's the most popular part in any development, so let's just put it and try to build a reactive streams on top of it, yeah? The simplest implementation could look like this. Why not just to say, send all the elements over onNext? That should work, right? But not in this case. Unfortunately, it won't work because there is specification, which says that there is 150,000 of rules. I'm joking. There is only 41, but this is enough to get crazy. So if you're going to look at this specification, we will see lots of rules for our publisher, for our subscriber, and lots for our subscription. There is a ton of kind of spots to make a mistake. And now we are going to look how to avoid all of them. So it's clear that there is lots of rules, but in order to start implementing something, I will just show you the central one, simplified version of Reactive Streams Specification in order to just start doing something. So the main rule is everything should be executed in order. So first of all, you have to call once on subscribe in order to send to your subscriber a subscription, so it's handshake. Then you have to start sending data after subscriber requested something. So it could be 0 data in case you don't have anything. Just imagine an empty streams, the publisher from empty stream. Or you can send infinitive stream of data because you can just get more and more elements into your array over the time. And finally, once you get the end of the stream, so this is a terminal signals like onError, onComplete, and they should appear once. So we have to get only onError once or only onComplete, and not both at the same time. It's unacceptable. Is it clear so far? Simple rule, right? Then, the rule related to back pressure. So if the subscriber requested 5 elements, we have to send 5 on next, and not more. We can send less, but not more. Then, this is a rule from Yegor Bugayenko. if you don't know him, this is a guy who cares about nullability. So he says that nullability is unacceptable in any cases. And I guess he put his hand on Reactive Streams Specification. It could be not true, but I just assume because Reactive Streams Specification prohibits null. So it's unacceptable to send null over on next. Why it's important? Just imagine that you process the stream of data. So you process normal elements over your next and next and next, and at some point in time you get null. What are your actions? Throw exception, return null, map null to something else. Is it okay to map null to something else? I don't think so. This is a point of question. What we have to do with null. Because if we return null, someone else should take care of this null. And it can cause some unacceptable exceptions, so this is a big problem. And it's rather acceptable to avoid it at all, prohibit it, rather than allows everyone to process nulls. Does it make sense? All right, so null is prohibited in reactive streams, and this is a good reason for that. Then, there is some corner cases. Just imagine that we requested one element, we received one element, we requested one element, we received one element, we requested one element, we received one element. We have to take care that in case of synchronous invocation of request and next, we won't get out of stack limit. Because we can easily get just the same action do in the cycle, so afterwards we will get stack overflows. So we'll have to protect ourselves from that, and this is a part of Reactive Streams Specification as well. Then, this is the simplest rule. If subscriber canceled from the stream, then we have to stop sending data, right? It's really simple. So, knowing those 5 rules, we can implement something today. And we are going to do that right now. So I'm switching to my project. And here is a really simple project. Can you recognize what's going on the screen? Should I make it a little bit more bigger? All right. So I'm gonna do font size 22. Is it better? Okay. Is it good for everyone there? Okay. So here's my application. Now I'm gonna just increase the project structure a little bit to show what's going on here. This is a plain Gradle project. We have our one main publisher with which we are going to play. And here, since we are going to follow TDD, because I'm a fan of TDD, and TDD is the correct way to implement something step by step, just applying refactoring, small refactoring. And in this way, it will be much more clear what we are going to do. We are going to use TDD, and we are going to implement tests first, and then implementation. Test and implementation, test and implementation. So this is what we are going to do, and now we are going to start. So let me switch to my array publisher. This is exactly the same code as you have seen on the slides. And now we have to write a test, because this is our main goal. So the first rules that we have seen today is that every signal should appear in particular order. So let me just, I have some code snippets, but the first test will be written just from scratch, because I want to explain you how you can write your own test afterwards. So I will be slowly create one first test, but then I will be using some code snippets in order to implement the whole test body. But this is just for beginning. I'm going to create the first test really slow and show you how you can test your own publisher afterwards. So now the first test is that every method in subscriber should be executed in particular order. So this is a test. Yeah, order. Now I have to create my publisher. This is clear. In order to start any testing, I have to get my subject of tests. So this is my publisher, and my publisher requires me to pass an array. So here I have a supportive method, like generate something, which allows me to generate a sequence of numbers, which will help me afterwards to test everything. So it's just 1, 2, 3, 4, 5, but I'm just saying, okay, I want 102 elements in array, or 1,000 of elements in my array. So it's easy to generate something. And now I'm going to use this method in order to generate, for example, 5 elements, in order to just start doing something. Yeah, one more points to emphasize. If you got any questions, if you want to clarify something, just let me know, and I will explain it. Don't be shy. Don't hesitate to ask me, so I will be able to double explain it afterwards. So I'm creating my array publisher. This is simplest part. And now I have to start doing something. So I have to subscribe in order to start verifying anything. And this is the first point in any reactive streams. I have to subscribe in order to start getting or observing my data. So I have to pass my subscriber. Here is my subscriber. And as you can see, subscriber has 4 methods in it. Unsubscribe, on next, on error, and on complete. This is really easy. And now I have to check that this guy was called first. Then it was a kind of received a few on next, and afterwards I get on error or on complete. So in order to check that, I will create the simplest solution. I will create just array list. Why not? And I will put some longs which indicate that it was called, for example, unsubscribe, or it could be strings, so it doesn't matter. So observed signals. And now I'm going to create this simple array. And what I'm going to do next, I will be doing something like this. I will say, OK, this was called unsubscribe. Then it was called on next with some specific element, for example, like this, in order to figure out that I received every data in particular order. So let me do everything in the same style. Then I'm going to put some on error, but I don't expect in this case that I will receive on error, so I will just put on complete observation, and that's it. So this is the simplest I can do right now in order to check only the first rule that everything should be in order. Of course, I have to say, OK, since there should be a reactive interaction with some back pressure support, I have to request some elements first, but this is fairly enough for me. Of course, since reactive streams could be asynchronous, you have to remember, in any test, the simplest way to await for completion is to create some countdown latch and say that this should be a countdown latch for one element. This is the simplest. So I'm using countdown latch. Once I received my incomplete signal, I will be ready to notify that I'm more than happy to complete my stream. So the person who is awaiting for completion should just put await method here, and this will be enough to check everything. So first of all, in order to make sure that stream has been completed, I have to make an assertion that latch returned to me a true. So it's the first signal like that, the first sign that everything went good. And the next step, what I have to check is that the signals I observed in my collection, observed signals, contains exactly, in particular order, first unsubscribe, since this is a first signal, right? First unsubscribe, then on next. Come on. On next with, what is with 0, then with 1, 2, 3, 4, 5. Yeah, 1, 2, 3, 4. And then on complete. On complete. Does it make sense, such verification? Yeah, it's pretty simple, right? It shouldn't question in you. So let's just run the test. Come on. Let's just run. Oh, yeah. I have to note, to state that this is a test, exactly. Yeah, so this is a test. I'm going to run my test, and I will see that it's failed. I expected that my stream will complete it in 1 second, because actually there is nothing to do, like just plain stream. But it wasn't happen because it's obvious. In our implementation, there is nothing related to incomplete signal, right? So the simplest implementation in order to satisfy all the requirements, of course, is to put incomplete. So we can do that like this, restart the test, and we will see that there is wrong series of signals. We expected unsubscribe at the very beginning, but it wasn't happen. So we have first, of course, put subscriber unsubscribe with some subscription. And now we can restart this test. And yeah, it's passed. Really easy. So it was the first requirement that we had to implement it. We implemented it. We serially call unsubscribe method with some subscription, then we call on next, and then we call on complete. Of course, it works, but we have much more tests. So the next test that we have to implement is, of course, related to backpressure support. This is the most important part of Reactive Streams. So we have to say, OK, test backpressure support. And now I magically implemented the test. Don't be afraid. I'm going to explain everything that's going on the screen. So no worries. What we have there, in order to test that my publisher supports backpressure, I did actually exactly the same. I generated an array of five elements, created my publisher, subscribed to my stream, but then I decided to move my subscription outside. Why I did that? First of all, I expect that someone will call me my unsubscribe method, but in order to check that I can control backpressure, I want to control it outside of my subscriber, like here, because here is my verification. So what I want to check first, if in case I didn't request anything, I shouldn't get anything. Does it make sense? Yeah, like it should be just empty collection. Then I request in one element. I expect that I will get exactly one element. One more elements in my collection. 2 elements, like 4 in total, and if I request 20, I should expect 5 and completion of my stream. Does it make sense? OK, great. So let's just start this test and see what will happen. And happens the following. We expected empty collection, but we got all the elements, right? So what's the problem? What is the problem? It's clear that there is nothing related to backpressure control. So we just send elements once we got a subscriber, and that's it. There is nothing related to request method. Any idea how to fix that? Your thoughts? What is? Yes, implement, but how? It's clear that we have to start sending something when somebody called request method, right? So what would be the simplest refactoring? So move this guy to... Huh? Yes, the simplest here is to just cut it out from subscriber method and put to request, because this is a place when we have to start sending something, and not earlier. So let's just restart this guy, and we will see what happened. Yeah, it passed. The first test was passed, but the second failed, because once we called the request, we got some n elements, but it's not used there. So we just send all elements to our subscriber, and that's it. So how to fix it? I guess the simplest fix is to use n, right? So we requested something, we have to send something. OK, let's just restart it. And here we go. This time we received 2 elements. We expected 2 elements, but the second one was 0. Why? Sorry? Right, because I'm starting from 0 every time the request method is called. So there is no state. We have to introduce some state, right? So the simplest implementation here will be introducing something like index. Does it make sense? Yeah, let's create integer index, and let's use this index here, and let's increment this index here. Everything should be golden. So let's just try to restart it. And again, it's failed. Why? Array index out of bounds. Exactly. That's the correct answer. Now we have to check, since we have a limited kind of amount of stream, and in case someone requested 20 elements, but we just iterated over all of them, we have to say, OK, this is a complete of the stream, so please, we don't have anything to use, so we have to just exit the execution. So if we're going to, we have to introduce some additional check, like that our index is less than array length. This is clear. And now we have to send our completion only when the index is equal to array size. Yeah, this is the check that we have to introduce and put here. And we have to just return here, and that's it. So now if we are going to run it, we will see that it's passed. Does it make sense? Great. So we did the first few steps, and we implemented the simplest implementation. It's still a little bit incorrect. First of all, because I'm not checking here the appearance of signals, but if you're going to put some system out println here on complete happened, we will see that this message will appear a few times. No, one time, okay. This is a good one, but in some cases, for example, if you're going to request a few more time, it will appear a few times, which is not good. If you wonder whether it's kind of allowed to request after completion, I will answer that no. Reactive Streams Specification says that once you got incomplete signal, it's prohibited to call any methods on subscription, because after termination, subscription is considered as canceled. Like, there is no subscription because there is no data for you, especially for you. So this is just an example, but you have to bear in mind that it's not allowed to call your subscription from incomplete or on error methods. All right, we implemented 2 tests, but we have much more. First of all, the next test is related to, yeah, question. This is a question which we are going to tackle a little bit later. So let's start from the simplest. Of course, could be multi-threading, but let's just implement it step by step. You will see why. Because there is enough rules that just require to build some blueprint of your publisher, and then afterwards we will implement some multi-threading interaction. But yeah, for now we have to finish the first 5 rules. The next rule is related to null verification. So we have to make sure that test nullability, where is that? Test NP, null pointer exception. And of course, this is test really simple. So what we are checking here, we subscribe it in the same way. We requested a few elements from our stream, but this is a tricky test. Our first element in our stream is null. So what we expect from our stream, from our publisher, is that our publisher will react or send normal signal to our subscriber. Because in reactive streams, everything is a signal. So we can't just throw an exception and that's it. We can't, because just imagine that your subscriber subscribed from a different thread, and now you are throwing your exception in thread A, but your subscriber is listening in thread B. So what will happen if you throw an exception in thread A? What will happen to thread B? Nothing. The answer is nothing. So we have to send proper signal to our subscriber in a proper way, in a proper channel like on error, in order to notify that something went wrong. So this is the only way to send exception in reactive streams, and no other way around. So let's just run this test and make sure that we got a proper signal notification, but not. We expected that we will get null pointer exception, but we got incomplete. So it's something we didn't expect, we don't expect. So let's try to fix it. The simplest fix here is just to say, okay, if we need to check that our array index could be nullable, if we have such requirement, so let's just put element outside of our sending, and let's just do element equal to null if there is element equal to null, we have to say in a normal way to our subscriber on error, new null pointer exception. And that's it. And afterwards, we have to return, because this is a terminal signal, so we don't have to send anything else, right? So let's just restart it. And here we go. We completed another challenge. So what else? Almost the lightest part, the final part of our verification is verify that we are not shot in our legs by recursion. So this is an important rule. And let's take a look at the test. So what we have here, the same set of kind of instantiation of our elements, like the same generation of our array. And now we create an array length with the length of 1,000 of elements, but in fact it could be much higher number of elements in your stream, because you don't know what kind of stream you will get. Anyways, we generate some stream, and now what we do, we receive this subscription, we put it in a field in a proper way. This is a proper way to store subscription. And then, once you received one element, you want to receive another one, because you can imagine that you have created some web server on your Arduino or on your Raspberry Pi. There is little small capacity of memory, of CPU, so you can request only for a few elements, but this is fine. So you requested another few elements. So you requested another few elements, you received a few, you requested a few, and so forth and so on. So what could go wrong? Everything should be fine with our implementation. So let's just run this test, and we will see Stack Overflow exception. And as we can see, by the way, this is a normal stack for all reactive streams. So you should expect appearance of such stack at some point in time. So afterwards, you will find out how to debug that. But yeah, we can see that Stack Overflow exception happened. And this is not good for us. So let's go to our implementation and take a look why it happened. So if you're going to follow the debugging or debugger, we will see that someone called a request with one element. Then we just took one element from our array and sent this one element. Back into our subscriber, we received this method invocation. So we put element to the collection and called request again. So we here again. And we are going in the same path. I would like to pay your attention that at the previous step, we are still on next. So let me just run this in the debug mode and show you what's going on here. Come on. Oh, yeah, I'm in publisher, so I have to run this guy. Yeah, it's running. So I got the first call to my onNext from onSubscribe. Do you see that? I was called from onSubscribe. And I was called from subscribe, which was called from my test. So it's so far so good. Yeah? Clear. So we in the first loop of request. At the point to send on next, so we are going deeper, and we are at on next. So we step over, enter the request, and we again at request. And the state of index is still 0. This is important. We are step over, we are taking the first element again, because we didn't finish the previous one iteration, so the index is the same. And we step in over and enter in on next. And this will happen so forth and so on, so forth and so on, until the end of the stack. And this is a problem. So any idea how we can solve that? Friends, now let's go think a little bit about that. How we can solve this problem. How we can protect this method from additional entering from another stack, if we are at the same stack before. Not sure that, like, you mean like moving on next outside of here? No, but how our subscriber will receive the element. So the idea that subscriber requests few more elements once it received some elements from our publisher. So the test could be absolutely different. So you can request for 5 elements because you know that capacity of the system, 100 of elements, or you have that much memory. It doesn't matter. At some point in time, you will say, okay, if my iterate, like I can have some index in my subscriber which count, for example, how many elements I received, but once I received half of them, I should request for another half in order to make my stream continue. So it could be absolutely different case, but anyways, we can't move this on next out of this iteration because we have to send some elements in order to invoke requests for a few more. Any other ideas? Let's just try. I have never tried it, but let's just try to do that. Anyways, we can do whatever we want. So let's just increase index. But let's just run it. Of course, we will send absolutely different elements right now, but the problem won't be solved. Yeah, we can do whatever we want anyways. Like the stack will be increasing, and the problem won't be solved. We can move to different thread. We will come to multi-threading back, but yeah, we can move. But the problem won't be solved anyways. The main reason because everyone, like imagine the case, you call it the request, someone received on next, then call it request. Then you schedule it another thread, which will send on next again, and you will spin up another thread. And if it happened too fast, you will create too many threads, so you will get like your memory overwhelmed in any case. So this is not the best solution. Of course, we can do whatever we want, but from my point of view, the simplest is to create some Boolean field, for example, or not Boolean, but just additional check-in. So in case, just imagine, in case we got a call, but we are already iterating, we have to just exit. We have to just say how many elements we want to get in addition, but we have to just put this number of elements and exit from iteration, right? That's what we have to do. And now, basic on these kind of assumptions that we have, once we started sending data, the other trying or attempt to enter the request method should end up with just increasing on some field and exiting from iteration. So it means that we have to create some request field or requested field, which will indicate how many elements we received by this moment in time. Does it make sense? Yeah, this will be the simplest solution. Of course, we can try to work around it by running some additional threads, but as I said, there is much more rules in specification which disallow you to do that. So the simplest way is to increment our requested to some number of elements. But now, along with that, we have to figure out that someone has already requested the first portion. Someone is already sending some elements to our subscriber, so we don't have to enter this part of the execution, but instead we have to just return. So to solve that, there is a pattern, well-known pattern in Reactive Streams, which is called work in progress. You can find it everywhere, and the idea of work in progress pattern is to allow in some field which is saying that someone is working at this point in time. And since requested indicates that someone has already requested data, and we will decrement this request field, for example, afterward, like here, or somewhere later, in order to make sure that we have sent all the elements and disallow everyone to just enter to this execution after with us. We can do that, for example, here. So we can just say, OK, requested equal to null, or we can rely on some field like this. So we can move our if field outside of our iteration, since this is a number of how many elements we have already sent to our subscriber, and rename it to send, for example, and decrement the requested field by number of sent elements. We can do either way, so it's just a preference of yours, but yeah, we can do like this. And now, what's the most important part? What we can do in order to prevent someone to enter the execution, we can create someone, call it initial requested, which will be equal to what we got before we incremented our request field. initial requested. And now we can increment our requested field for some n elements and then do some checking. If initial requested is not equal to 0, it means that someone is already, not like this. It means that someone has already in their data sending field in for loop, so we have to just return. And if we're going to run this test, it will solve our problem at all. So let's just run it. Let me just remove, yeah, we can debug it, by the way. So this is the first entrance of the execution. So now I'm going to enter a next. Now I'm going to enter request. And as you can see, initial requested is 1. Before it was 0, now it's 1. So we just increment requested field. And since this is initial requested is not equal to 0, we have to just exit. So once we return the next method, we will be able to continue our iteration without any problems. Does it make sense? Yeah? But now we have another problem. Yeah, it's not finalized. So we got a hanged test, first of all, because we have to use this requested instead of n right now. Because n is just a static field, so we have to put requested instead. And now if we're going to run the same test, we will see that it will work like a charm. So, any questions so far? Yeah?
Why does the chain of requests does not cut off if we just respond to the request without doing anything?
For example, how?
Yeah, in line 37, you just return without doing anything.
Yep.
Why does this not make the chain of requests and responses cut off?
No, it won't be cut off, because we have a loop of sending data from our array. So we know that once we have some specific number of requested elements, we would have to iterate until we send all of them, right? So we have number of sent element, we have number of requested element. So if we're going to request some elements from a next, this field, which indicate how many elements we have requested, we have to send, will be increased. So once we exit, once we return from this request without sending elements, we will get back to this point in time, and then we will iterate over it again, and we will send next element. That's why this is the simplest solution. We don't have to create some, just imagine that we will try to send from this point in time, or we will try to work around that. You will end up with really complex code, and this solution is the simplest one. Yeah, I'm recommending you to repeat that at home to try absolutely different ways. But yeah, for now, we will try to achieve the simplest one. Yep, does it make sense? All right, so what you have to remember here, that this part of code, you will see it everywhere, this part of code is called work in progress. So there is a field which indicates how many requests or how many attempts to enter this execution happened by this moment in time. So afterwards, you will be able to satisfy all of them, because you have the state which indicates how many were requested. Yep. Yeah, okay, good question. So the question is there any kind of abstract implementation that I can reuse at any point in time without any problems? So in fact, since Reactive Streams is part of JDK 9, so you can find it, for example, if you Google, let's call it Google. Yeah, I'm using JDK 8, so if I'm going to switch to JDK, for example, 11, or like higher than 9, for example, in my case, it could be JDK 12. You will find that there is something called flow, and this is part of Java util concurrency, like concurrent package. And inside this Java util concurrent, there is all this Reactive Streams interfaces as a part of standard library. This is good sign. Like this Reactive Streams library were ported to JDK. And of course, there is one standard in JDK. So there is, it's processor. So if you're going to look for a publisher, there is one. Yeah, I'm just showing for your knowledge. Where is that? No, it's not here. It's not there. So it should be pull publisher. Yeah, submission publisher. So there is one abstract, but in advance I don't recommend to use it because it's too slow. The implementation is really slow and kind of shitty, and it relies on some executor. So if you want to create one publisher, then another publisher, then another publisher using this submission publisher, you will get too much overhead afterwards. So you don't need it. You can try to build something on top, but it's not the correct way. In general, you don't have ever create your own publisher because there is all kind of implementation in existing libraries. Now what we are doing is we are trying to figure out why those libraries, why those internals of Project Reactor or XJava were created in the way they created, right? What patterns they try to follow in order to make them super fast. That's the main idea for now. All right, does it make sense? Yeah, let's continue. So yeah, we are almost there. We are almost there. So the final test that we have to implement right now is the test related to cancellation. So since we have to stop at some point in time our stream, what we have to test, like this is the simplest I can figure out, is that once I get a subscription and I canceled it, I should never get any elements afterwards. So what I do here, I cancel my subscription and I request. This is a tricky test. You don't have to do that at home. But in general, this is a way to test that your publisher violates the specification. And that what I expect here is that my collection will be empty. So once I assert this collection, I expect that it will be really empty, and that's it, right? And what more is more important, that all other signals shouldn't be called here. So onComplete should not appear. So what I have to add here is something like this. So I have to check that this guy will return false. So it will be false. So I will wait for a second, and then nothing should appear. This is the main idea of this test. So let me just run it. And what we will see that it will be thrown, because we will get all elements, all kind of elements, and we will get completion of the stream, because nothing prevents in our implementation against cancellation. We don't have anything that say, okay, this stream is canceled. Any idea how to fix it? Huh? Yes, of course, the simplest implementation is to say we have Boolean flag, which is called literally canceled, which means a canceled stream. So this flag will be turned into true once someone will call cancel method. And what we are going to do here, we will just simply try to rely on this flag and do something like that. If canceled, then just return. If canceled, please return and don't do anything else. And that's it, right? Does it make sense? Like to put these flags, of course we can put it somewhere else, we can put it here, but the effect will be the same, like it doesn't matter. So now we are going to run this guy. Oh, not this guy, but this guy. And here we go. The test is passed. Yep. So far, so good. Any questions regarding the implementation? Yeah? Any? Yeah, of course, this is kind of the first steps. But so far, we implemented only 1, 2, like how many? 5 tests, as I said. However, the specification is much more complex. There is 41 rules. And now the question, do you want to write all of them? Do you like to write tests in your project? Who likes write tests? Oh, yeah, the others is more fair, like because no one likes to write tests. Even I don't like to write tests because sometimes it's too boring. Believe me, sometimes it's really boring, and we want to just focus on business logic, and that's it, and we will test it afterwards. That's what we are saying to ourselves. That's how we are lying to ourselves. And of course, this is not good. And nobody wants to rewrite the same kind of test again and again and again. That's why the developers of Reactive Streams Specification took care of us. And they created somewhat call it Reactive Streams TCK. Do you know what TCK means, by the way? I would answer. Yeah, this is kind of test case or technology compatibility kit. So it's a set of tests that allows you to test your publisher against the specification. So basically what you have to do, you have to bring one dependency into your project like this. So here's my build Gradle. I have already got one here, but in general what you have to do, you have to put one dependency in your project, and what you will get afterwards, you will get a set of verification for everything, for your subscriber, for your publisher, for your subscription. And as you can see, there is a few verifications, but for now, the most interesting for us is publisher verification. This is abstract class, which extends the interface, which basically implements all possible tests. Do you see it? This is exactly all kind of rules that verifies that there is no recursion in our stream. So this is exactly the same test that we implemented ourselves. There is a test related to back pressure control, which tests that if we request one element, we must receive only one element and not more, and then completion. And so forth and so on. So there is all kind of tests that we need in order to make sure that our implementation is absolutely correct. So it should simplify our life a lot. And what we have to do right now in order to make this working with our project, we have to extend publisher verification. So the most important part that in general this verification is generic. In our case, our publisher produces longs because we have generic publisher as well, but we test that our publisher returns stream of longs. And now we have to implement a few methods here. First one, the one which returns kind of a working publisher. So in order to make verification running, you have to provide an instance of your publisher. So what you have to do here, you have to create your array publisher. You have to supply a stream. In your case, we have a supportive method called generate, which allows us to generate exactly the requested number of elements from our test. There is another method which requires you to pass a failing publisher. So just imagine that you have a publisher that just return error. So there is a test for such publisher as well. But since in our case, we consider our publisher just working, we can return null, and it will skip all tests related to failure cases or failure verification. So afterwards, in order to make this test just running in parallel environment, we have to supply some environment setup. By default, what you have to do, you have to just create default one environment, and that's it. And it will allow test ng to run your test in parallel. So does it make sense? Any questions so far? So now if we are going to run our test suite, we will see all this set of tests to be running. I will just increase it, enlarge it, and you will see. All these tests are almost passing for our publisher. There is a few tests that verifies that in case someone requested negative number of elements, just imagine that your publisher got crazy and said, okay, I want a minus 5 elements. Does it make any sense to your publisher? Yeah, you can't just get back what you have already sent, yeah? Or you can't decrease the number of requested elements. It's illegal again, because someone expected a few more elements. So due to the specification, negative number of requests is a legal number of requests. And in case your subscriber requested negative number or 0 of elements, it means that mass that calculates number for request got in the wrong way, and your publisher got crazy. So you have to just say on error and stop sending anything and terminate your subscriber for a good time. Does it make sense? Yeah, that makes. Great. So let's just fix this part. In order to fix it, we have to add a few verifications. This verification is really simple. I will use some code snippet, and what we have to do, we have to check if the number of requested elements is less than 0, and if we are not canceled yet, we have to cancel our subscription. So we are going to cancel ourselves in order to say, okay, we are canceled. Now, why we are doing that? Because just imagine that someone requests or call your request method in a synchronous or in parallel way, and you can get 2 - 1 requests, and you will end up with 2 on error signals, which is illegal, right? So we have to somehow prevent sending additional termination signal once we got one. We have to say, okay, we are canceled. It means that we will be able to not send incomplete here. So we will prevent sending incomplete here. And in the same way, if someone requests -1 again, we will be able to say, okay, we are already canceled, so please just get out from here. Does it make sense? Yeah, really simple. So now if you're going to rerun all of our test suite, we will see that everything is passing. Hooray! Yeah, we are good. We are at the first stage. So let's just quick sum up, and we will do some break in order to get together everything. But let's do some quick sum up. First of all, I want to ask a question to you. What's wrong on this schema? Any idea? No. There is. Let me go back to the previous slide, which runs the schema. So we are doing, is it correct? Do we really request elements from our publisher, and publisher sends elements to us? Is it correct way of showing this? Yes. Everything happens with subscription and oversubscription. So if you're going to look at this schema afterwards, after this implementation, we can see that all interaction is happening with your subscription. And publisher has no kind of relation to this, to data sending. So your subscription sending a data to you, and that's it. The publisher is just a wrapper of your subscription. So once you start debugging reactive streams, once you start looking at flux array, once you start looking at flux iterable or whatever flux, at whatever source, you have to start looking at subscription. This is the first entry point, because subscription is responsible for data sending. And once you want to debug your stream, once you want to figure out how many elements is requested, you have to put breakpoint into your subscription. And the most important part, in order to catch the request or data sending process, you have to bypass work in progress, because you will see that in real implementations, there is the same work in progress pattern. So in order to figure out what elements are sending, you have to put breakpoint somewhere here. And then you will be able to catch it for sure. Right? Does it make sense? Yeah, this is the first you have to remember. All right. Next, work in progress. This is the most common pattern for reactive streams. You will see it everywhere. It is implemented in the first steps like this. So we just check what was initially requested. We increment the number of requested elements. And if the check is not passing, we have to just return, because someone is sending elements already. Then, in order to check our implementation against all the rules, we have to use TCK. This is the simplest way to start building something. Once you get home, you have to just want to create publisher or repeat the same actions, try to extend TCK, and start doing all implementation from TCK, running TCK tests instead of creating your own. In general, it seems that it just works. Tests are passing, but unfortunately, the life is a little bit more complex than just our implementation, because we are living in multi-threading. At this point, let's do some break. Let's take some 5 minutes coffee or 10 minutes for coffee, and I'm looking forward to see you afterwards.